My name is Srini. I am from Aryaka. Ritu Sood couldn't join today, so I'll be covering most of the presentation. My intention of this presentation is to show that open source projects are relevant for network security also. And many times you might have heard open source projects in the context of networking, switching, routing, and orchestration and management. But you might not have heard about network security using open source projects. I also can say that we tried this ZTNA project using open source with almost no modifications to open source projects. And I also can say that some of the final outcome, we believe that it is actually features was rich compared to existing commercial products, right? With that background, so what I'm going to talk about is that how are things in the enterprise before this ZTNA, right? I want to give introduction to ZTNA first. Then how enterprise applications get secured using ZTNA, and how we are leveraging Kubernetes, service mesh, and EMCO project to realize ZTNA. So this is a big picture. A lot of acronyms here. SASE is Secure Access Service Edge. It is the term is coined by Gartner. It's really a network security stack, right? Provided as a service. And that's what really SASE is all about. So if you look at this picture, any enterprise would have clients, employees, contractors, consultants, and even some devices. Other enterprises also have their applications, typically the on-prem data centers. Nowadays, of course, cloud computing also now, using infrastructure as a service. And employees need to access internet, and employees need to access enterprise subscribed SaaS services. So network security comes in between clients and enterprise apps and data, right? Predominantly, of course, the bottom mostly is SD-WAN. You require some kind of a WAN connectivity, connecting your clients to the services. And of course, this becomes super important because of the COVID, like your employees are distributed. So you require the SD-WAN connectivity across multiple geographic locations. And firewall is a basic foundational security. And ZTNA is meant for securing the applications in enterprise data centers or enterprise VPCs. Just to complete the picture, there's something called CASB, Cloud Access Security Broker. It is meant to secure data of enterprise in SaaS services, right? And the topmost one is internet access. Like here, you want to secure your employees from going to malware sites or phishing sites and things of that nature. So that's secure internet access. Today, my presentation is about ZTNA, Zero Trust Network Access. Okay, how was security provided for enterprise applications before ZTNA? Of course, enterprises have applications for a long time. They do need to have security. It was there. But how is it done before, right? This is the kind of a big picture. Again, on the left side, you see clients in different branch offices or in different offices, and also some clients which are working from home or working remotely. They're all basically accessing enterprise applications on the right side, right? Wherever our apps are there, that's where enterprises brought their security. One is VPN gateway for data security between clients and services. And then you also have a threat protection, web application firewall, API security, and some kind of a load balancer to balance traffic across multiple application instances, right? For scale-out reasons. That's the typical architecture before ZTNA was invented. What are some of the challenges here, right? The problem, one of the biggest problem before ZTNA is that the clients basically, if they are in this virtual private network, they are given access to the applications, right? There is some kind of access control, like firewall is there along with the VPN gateway. They provide access control saying that any access coming from this subnet of IP addresses, I would allow access to my application, which is okay to a great extent. But the problem is that nowadays we have attacks, okay? Well, let's say one client got infected, and then the client basically they can infect applications, right? That they call lateral attacks. So in those cases, since client got infected, he's already part of the subnet, he gets the same access, the malware or whatever that bad guy will get the same access to your applications, right? And second thing is that if you have a insider who is not supposed to be accessing the application, but he can access now because the access control is at the IP subnet level, but not at individual user level, right? That is one of the challenge. Second challenge is reconnaissance, right? That is the first stage of any attack, right? Now that all apps are basically available, they are visible for anybody, any client in that particular networks or in the offices, right? That means if somebody got infected, they can basically do port scanning and find out all applications that are there in that network. So that is something which is not a good thing at all, right? And they're prone to DDoS attacks. Again, any infected client can basically send lots of attack traffic or traffic in general, volumetric traffic, to ensure that apps are not available for genuine clients. So that is one big challenge here, because at the end of the day here, data centers have got WAN connectivity which is limited in bandwidth, maybe 1 Gbps or 2 Gbps. So it's possible for some client to really exhaust the WAN bandwidth, right? And then in this architecture, they also assume that applications are developed very well. So basically they provide SSL TLS termination, they do certificate management very well, and they also provide some kind of RBAC, least privilege access, everything they assume that. So that's not really true. Nowadays application developers, they really want to bring the applications so fast, and they don't want to worry about security aspects at all. So this particular architecture doesn't take care of security aspects of applications. So they assume that apps are built properly. So that's also a wrong assumption. And from the management challenges perspective, there are many boxes there, right? VPN gateway coming from one vendor, WAF coming from other vendor. So that becomes complex. If you really want, every vendor has got their own management dashboard. Okay, that's a discrete dashboards is a painful. And then today it may be okay because you have only few data centers, but as you move to edge computing, as you move to cloud computing, there would be large number of places where you want to deploy applications, right, for better user experience. So that becomes even more complex from the management perspective. Then auto scaling is not there today. I mean, in that period before, like it's a physical appliances typically, all these security boxes. And if you need more compute power, then you have to go and refresh your hardware, right? That's not good at all. It's not, there's no cloud concept at that time. And then if you have a remote users, they require some VPN client installed in those remote laptops, right? And that is basically you don't have bring your own device kind of concept. And then there was no cloud busting, multi-cloud support required at that time, right? These are some of the challenges. Then of course, industry moved to cloud security. Like instead of having heavy boxes at each data center, some of the cloud security vendors, they provide most of the security functions in the cloud, right, in between somewhere. Okay, so it addressed quite a number of challenges which I talked about. Okay, for example, the DDoS attacks are no longer a problem because the cloud security uses cloud principles. So if there is a more bandwidth required, they bring up another instance of cloud security or WAF or VPN concentrator. So that way, even if there is a bad actor, even with pumping a lot of data, you keep increasing your number of instances, right? So you could address that. But there are some other challenges still there. Whatever is not knocked off there, there continues to be there. But still, bad actors can basically look at applications, like by doing port scanning. And all the other challenges are still there. And there are some more challenges came in picture because of this, right? Now think about clients accessing the application in the same data center, right? Now, because security is over here, there is a hairpinning. The traffic coming from this to this now has to go all the way here and come back. So that's a hairpinning challenge, right? And then there are multiple POPs, especially if you're going with one vendor for SD-WAN or one provider for SD-WAN and security from some other provider, then there is a multiple hops where traffic has to go through. Those are the other challenges got introduced because of the cloud security. So with the ZTNA, the idea is that it is part of the SASE, and the same SD-WAN vendor provides security also. Okay, and the main thing is that ZTNA is a reverse proxy, and because of that, you don't need any special VPN client to be installed in every laptop, right? You could bring your own device. And the other main important thing is that it's an ID-centric security, right? So it's not IP address based anymore. That's why it's called zero trust, really. So people have to log in or successfully log into ZTNA before they get access to the application, right? And because of that, you are basically eliminating many reconnaissance attacks, and you're also providing the access only when authenticated, means like if there is a malware or if there's an insider, they really cannot get into the application, right? And then it also acts as a global traffic load balancer. Suppose if you have your application instantiated in your data center as well as in the VPCs, let's say, because of cloud busting reasons or multi-cloud reasons, or because you want to deploy in edges to provide good user experience to your users. So you may be having your API, your application instantiated multiple times in multiple locations, in which case you also require some kind of a load balancing, or some kind of a choosing the right location, and then if the location has got multiple instances, then you need to load balance. So that ZTNA takes care of that. And normally it's delivered by SASE providers, hence you don't have this problem of multi-hop problems. And ZTNA is also, can be instanced anywhere, not only in the POP locations or cloud, but also in your data centers or even in your branch offices, right? And because of that, you don't have that hairpinning issue. So that's why the ZTNA people call it is a distributed data plane with a single management plane. So with ZTNA, almost every challenge which I listed down before is basically taken care. Okay, I was showing some different traffic flows. Without hairpinning, you are basically able to address. So let me go to the next slide. So why cloud native for SASE and ZTNA, right? And as you know, in the application world, developers started to use cloud native infrastructure, which actually takes care of cloud native principles, right? And as you might have heard from multiple people, that when people develop applications, more than 50% of the application development is not related to business logic. It is all about surrounding areas, right? Whether it is auto scaling perspective, resiliency perspective, ensure that if the application is not misbehaving, restart kind of thing, self-healing or whatever people call, and ensuring that application runs in anywhere, whether Azure or GCP or AWS or some edge tomorrow, right? And it needs to be secure, right? And then it has to be manageable automation. So all these things basically take more than 50% of the developers' work. Okay, that's where developers started to find that cloud native infrastructure can help in reducing the amount of work they need to do for non-business logic functionality, right? And same is true with the network functions too, or security functions too. So we believe that by leveraging cloud native infrastructure and open source projects, we could reduce, as a developer, the ZTNA development from 1 year to maybe 6 months, right? So In this project, we basically leveraged cloud-native infrastructure, which is Kubernetes, right? Which is basically providing all of these cloud-native principles. And then, of course, Kubernetes itself is not good enough. We also need to use some ecosystem projects like MetalLB, which is a load balancer, and the external DNS, which actually updates the domain name entries into Power DNS. Calico is a CNI. And EMCO is very important. It's a multi-cluster service orchestrator, right? Now, I talked about, in the previous slide, where ZTNA needs to be instantiated in multiple locations, right? Multiple edge locations, multiple data centers, multiple public cloud locations. So when you have so many ZTNA instances, you require some multi-cluster orchestrator to deploy ZTNA everywhere and configure ZTNA properly to work. So you cannot go to each location and then configure, right? So that's where Project EMCO comes into picture. So it has the ability to deploy across multiple Kubernetes clusters. So this is the open source stack which we have used, right? And of course, each ZTNA instance is running on a Kubernetes cluster. And of course, you could have multiple ZTNA instances as I talked before. Of course, Kubernetes always uses Linux. And we're also using IPTables, which is already built into the Linux operating system. And Kubernetes provides horizontal pod autoscaler. Whenever, let's say, one pod is basically getting consumed, CPU, then Kubernetes has the ability to bring up another pod instance, another pod of that application, or in this case, ZTNA, CNF. And then Kubernetes also has a internal load balancing functionality to balance the traffic across multiple instances, right? It's all Kubernetes gives that all that stuff. So that HPA. And vertical scalar is, whenever you have, let's say, Kubernetes cluster is running on 2 compute nodes today, 2 VMs or whatever it is, and then you are running out of CPU because of multiple pods and because of auto scale out of pods, then it is an ability to bring up new VM or new compute node attached to the Kubernetes cluster, right? All that stuff is there in Kubernetes already. Then MetalLB, it's a kind of an external load balancer. So here I talked about HPA also load balancer, that is the internal load balancer, but MetalLB is from external traffic to come to the front-end microservices. So there is a lot of ecosystem projects here. We have used them. And then ZTNA, as I mentioned, it is a service. Hence, you would have multiple tenants, multiple customers for that provider. So we are using network namespaces of Kubernetes for each customer, right? For each customer, one namespace, and then all these functions are instantiated on per customer basis. That means these functions would be there as many customers as you have on that Kubernetes cluster, right? So ISTIO Envoy, that is a service mesh, which we're using it for reverse proxy, and Strongswan for VPN concentrator. Flux is for Git synchronization, Git repository synchronization. And OAuth2 proxy is for, as I said, the ZTNA main intention is to authenticate users before allowing the access, right? So OAuth2 is the OAuth2 proxy provides OIDC, OpenID connector, which allows you to authenticate users using OAuth2, right? And the OAuth2 with Keycloak. Keycloak is a broker, is a authentication broker. So some customers may have, maybe AD authentication. Some customers may have Okta IDP server. Some may have ping identity. So everybody may have different authentication systems. This Keycloak broker is an open source project, basically acts as on one end you can only support OIDC, on the other back end you can support multiple authentication protocols. So that is a broker. Then Apache Guacamole is a project which webifies SSH and RDP and other things, right? So Vault is basically to secure your private keys and passwords and things of that nature. And there are 2 more projects, KNRC and KNCC. This is called Kubernetes Native RESTful Controller. Idea is that, a lot of CNFs, right, they're not Kubernetes ready before. So they were exposing RESTful APIs for configuration. But as a Kubernetes, you want everything to be a custom resource or Kubernetes resource, right? But again, you don't want to develop operator for every pod, every network function here. Right? You may want to just, that's why we created something called KNRs in the LFN, which actually exposes RESTful API resources as a Kubernetes resources. Okay, that way any multi-cluster orchestrator, they don't have to worry about talking to RESTful APIs. They only need to talk to Kubernetes via custom resources. Same is true with KNCC, which is a config map controller. Like you provide a CR to modify or edit config maps. Like for example, MetalLB, Core DNS, they don't have any APIs. You have to modify the config map for any incremental configuration. And KNCC basically allows you to modify config map incrementally, right? Cert Manager is another open source project. You could use it for certificate management, right? And then this is where we are using EMCO, it's the central management entity. EMCO is basically can deploy all these things across multiple ZTA instances for each customer. It deploys these components on demand basis. Like when customer signs up, you bring up. And when customer says that I want ZTNA instance to be made available in 30 places, okay, you bring up these components in 30 places in different Kubernetes clusters. Okay. All the green ones are basically the ones which the ZTNA developers need to worry about. Everything else, you get it from open source. Like we also used Grafana, Cortex, and Loki, along with Prometheus for observability stack, right? So it is just really it's an integration of multiple open source projects. Of course, it's not an easy work. It took almost 6 months to do this because there are so many configuration parameters and so many things we need to do here and there. But finally, it works, right? And you can check that repo. That's where all the integration items were placed. So this is the kind of whatever I described, with respect to multiple components which are there here and what they are used for, right? MetalLB we use for BGP-based load balancing, okay? And Envoy as a reverse proxy and front end, and also Envoy reverse proxy. Now with this, actually one of the features which I talked about is as application developer, you don't have to worry about security at all. You just develop based on your business logic. And ZTNA with Envoy here takes care of terminating SSL TLS connections, take care of certificate expiry, certificate renewal, certificate management, all the aspects. And it also takes care of, if you develop your application using APIs, it also can take care of authentication and also provide least privilege access using authorization policies of Envoy, right? You can say that only this API should be accessible for this kind of users, right? You can put that granularity. So with that, you may know that 40% of the vulnerabilities today in applications are because of this authentication, authorization problems, right? It's called privilege escalation. That's the term which NIST uses. So those problems are taken away if you use ZTNA, and an Envoy proxy with ISTIO is providing very good capabilities. So in conclusion, network security industry is just like application industry, right? They also need same cloud native principles, auto-scaling, resiliency, or self-healing, whatever you want to call, and you should be able to run anywhere. You don't want to develop, put effort to bring it on in different cloud providers and edge providers tomorrow. So you want to develop once, and then it should be able to be deployable anywhere. And security, as I said, application developers don't want to worry about security. Okay, and same is true here. Okay, there are some. It may not be exactly same as applications because ZTNA is actually providing security for applications, but it itself has some infrastructure security items like passwords. You want to secure them using HSMs, right, via Vault, right? And manageability observability is same concept. Like you want your support guys to basically have one single dashboard for all security functions, and then irrespective of whether you have 20 POP locations or 100 POP locations, you should not matter to them, right? And we believe that Kubernetes and its ecosystem and EMCO project can help away the infrastructure pieces required for network functions. Okay, and please check the open source projects. And ZTNA is one use case we started with, and we believe that all SASE functions, whether it is SWG, so Secure Web Gateway, or CASB, can leverage the same open source projects too. And I would call out this one. Service mesh is the key for many SASE functions, because service mesh was created, by Lyft, especially the Envoy proxy portion, and any security function today, they are not running anymore on per packet basis, right? They are basically require content to be, collected before they do either data loss prevention checks or anti-malware checks. You require data. That means you require proxy to be there. Like proxy is the only way you can basically collect data across multiple packets. So, and the Envoy proxy is very good. Today, it acts as a reverse proxy, and it also acts as a transparent proxy. And then we basically, when I was at Intel, we basically contributed quite a number of patches into the Envoy to make it as a forward proxy. That way you can use Envoy for all kinds of security. Okay. And I put the link where we put all this information on realizing this SaaS, ZTNA using open source projects. Please check that out and see whether you can use it and contribute if you can. So I'll stop here. If you have any questions.
Yeah, I got a question. I think you may have given an impression that developer doesn't need to think about security because you're providing network security. But there are applications where application security and data security is utmost important.
Okay.
Especially in an insider threat situation, your network boundaries can't protect you from that.
Yeah, so I was talking about from the SSL, TLS perspective. Like application developers don't have to worry about providing TLS security anymore because this ZTNA can front-end applications. And similarly, I'm also talking about authentication authorization aspect of it because, at the end of the day, even application does authentication. They also need to implement OIDC, that kind of protocols to authenticate users. And then the applications develop even authorization also, RBAC or whatever it is. They need to basically provide some kind of this API need to be accessible only by users of this group and role. At least those three network security aspects don't have to be taken care of by applications. It can be taken care of by ZTNA. That way, business logic can be implemented faster. But as you said, there are other aspects, right? Like in the, for example, misconfigurations. Like nowadays, there is a concept called CNAP, right? Cloud Native Application Protection Platforms. The idea behind them is that, that's nothing to do with network security, though. It's all about, your applications are using some cloud provider services like Amazon S3, right? And if somebody configures Amazon S3 service badly, that means anybody can basically look at your data. So that is different. Like there are basically, I categorize security into three buckets: endpoint security from the client security, which is not in the scope of SASE, and then cloud security or the CNAP, that is at the service level. SASE comes into network security. So yeah, you're right. It requires all three of them. Yeah.
How far do you see that we can start seeing this becoming some standard, some network deployments, for example?
Okay, can you repeat that? I'm sorry, I couldn't hear you.
You can hear me?
Yeah.
How far away are we, technologically speaking, and also like readiness for this to have to become a standard in current network security, right? I mean, speaking about zero trust network enhancements and everything related to zero trust itself. Because, like you mentioned at the beginning, we need to think differently of the way that we were handling security itself. before we focus on specific aspects of security that were not like mostly relevant to the technologies that we were using, but for zero trust networking, we need to see everything as a whole itself,
Holistically, yeah.
right? So you were working with this, I think, for quite some time. So how do you see that the level of readiness for it to become some standard in the way that the industry is behaving?
Yeah, I don't think there is any standards today, unfortunately, on this. I think open source is the way to bring some kind of a ad hoc standardization, if you want to call that way. So for example, that Envoy proxy, which I was talking about, they provide something called extensible architecture today. Okay, so you could bring, for example, WASM plugins,
Yes.
okay, as a security, as a WASM plugins or Lua scripts or C++ plugins, right? So I say that, since Envoy proxy becoming so popular, many security vendors started to, provide, either their security as a WASM plugins or C++ plugins, which matches with whatever Envoy exposes. So I see that kind of standardization. It's kind of a de facto standardization, but otherwise there is no IETF standards or something like that happening in this area.
Not yet, but do you think you will see it as a requirement, right? I think there is something that needs to be.
Yeah. For example, I'm not saying that IETF doesn't have it. For example, in the same scenario which I explained, there's something called ICAP. ICAP was there almost 10 years back. It was standardized to allow any proxy to talk to any security function, right? It's called ICAP. But the challenge with ICAP is that, of course, people are using it now, but the performance, because ICAP is over HTTP again, right? So you're terminating HTTP connection, and you're collecting the data from HTTP connection from the client, and sending it over another HTTP connection to the ICAP server. So your performance goes very bad. That's the reason everybody likes to have whatever people call single pass architecture. Okay, that means within a single user space process, and you want all security functions to be executed without any copies. So that's the reason I am saying that, this today Envoy proxy, they're exposing some interfaces, and that's becoming standard. Yeah.
Thank you.
Yeah.
Thank you very much.
Any other questions?
I got a question on your thoughts on the sort of making that policy. It seems like you have to deploy this ZTNA software, and there will be at least either on the endpoint or edge of a clustered network, some sort of policy enforcement machine.
Yeah. So that's what I was saying. Envoy proxy today, even though it was designed initially as a traffic management software, like for load balancing at the level of APIs, but now Envoy proxy has good support for authentication, along with other projects, of course, WAF to proxy, Keycloak for authentication. And they also have very good authorization engine today at the API level. So you could look at the URL, you could look at the method, and you could look at the request headers, and you can say that if this match, and if the user is of this particular role or group, then only provide access. They're very granular. Of course, at the same time, for some use cases, that may not be sufficient. And Envoy proxy, again, supports something called external authorization interface. So if you don't like whatever authorization scheme that is provided by Envoy, you could develop your own authorization module. So it's pretty flexible. And some vendors do that, by the way. Some developers go and develop their own authorization engine. But I would say that, the existing authorization module, the inbuilt that is there in Envoy is pretty good.
Did you still see the ISTIO and Envoy playing that role of enforcement
Yes.
per session?
Yeah, but not only per session, per API. per HTTP transaction and per API level. It can do that kind of a deeper access control.
Okay. But would it be granular enough to go inside the API for messages?
Yes, yes, yeah, it can.
Well, thanks for sharing with us. I think it's a pretty novel idea to pull it off of with all these open source software.
Yeah,
And I think to answer his question, right, it's always going to be supportability, right? Do I download all these 15 different components and I'm the integrator and I'm the supporter versus, like.
that's where you need to come to Aryaka. We do that.
But I kind of figure why you left Intel and you got a different company name now.
Yeah, yeah. So we provide managed services.
Very
Thank you.
good.